a quadratic. You want to factorize it. The numbers look suspicious. You have factors across with numbers at the top there. See, everything is divisible by 2. It's a sure sign that maybe there's an easier way of doing this. So we're going to take the 2 out and keep it there. It's not going to divide through and disappear. So we take the 2 out, means we're going to divide everything that we had before by the 2. And then we're going to see that the resulting quadratic in a bracket is nicer. How do I know it's nicer? Kind of a guess, but we see 21 has got some factors that interact nicely with 4. So let's see how that plays out. Keep everything in line is a good tip. I know this is probably going to work, so I'm going to go ahead and draw my double brackets. That's not to say that it might have been a quadratic formula that needed to be used here, but if we were going to do that, we would have done it from the beginning. So we're going to have R and R. 21 has factors of 3 and 7, and I'm pretty sure I can get a 4 with that. So R plus 7 subtract 3, and that's going to get me my quadratic equation factorized. You can see a video I've made on quadratic factorization in many different forms. This will be the basic one. And some people like to combine the 2 in. Just like you can combine the negative in, you can combine the 2. So what I'll pick to put that into the front bracket, so everything gets an upgrade. The second bracket is another factor. It's unaffected. Since they're all multiplied together, we can just multiply the first 2. And actually, it's probably neater to have it in that form. You can see that you could have gone from the original question straight to there if you decided that you wanted to. The motivation here was to make the factorization of the quadratic easier by noticing a common factor across all the terms. So example number 2 then, it's going to be the same thing. It looks pretty nasty, and it might be a case that you want to use a quadratic formula, but I don't know, maybe you're stuck without a calculator, and there might be a better way of writing it. Let's try and take the 0.7 out and see if it is better. We divide by 8 what we took out, so we're left with h squared. 2.8 divided by 7, that's going to leave us with 4. And then 8.4 is like 84. So divided by 7, we get 12. And it is nicer. So 0.7 is preserved, and it looks like I'm going to be going ahead with 6 and 2 here. So h plus 6, h subtract 2, which will give me my plus 4. And do you want to integrate and bring that back in? Maybe if I wrote it as 7/10, might be interesting to bring it back in. Might be easier to write. So let's just see if we prefer it. Only one way to find out sometimes. 7h over 10, and then you've got 7 times 6, which is 42, divided by 10. It's quite good. I'm now regretting the fraction because it's turned back to a decimal anyway, so there we go. Do I like it more? Not really. Generally don't prefer decimals. Seems to be people start off life preferring decimals, and then eventually fractions win. Let's have a look at the last one. Ooh. I think if we take a third out here, we might not be in a case. It's not the nicest, but we'll see what happens. So that's a third. If we take that out, that's quite difficult in a sense, because if we divide by a third, it's like times in by 5. So minus 15. Oh, it's only a positive, yeah, so it remains. And then divided by a third is like times by 3, so we've got plus 36. Can we see 2 factors there? It's probably 12 and 3, isn't it? So let's see if that works out for us. We have f both brackets. 12 and 3, how do we get to minus 50? We have to subtract both. Certainly works to get the minus 15 and then we get the positive 36 that way. Pretty much as far as we can go there. But I mean, what more could we do? Perhaps we put the third in to the second bracket. So we have f over 3 minus 1. Maybe that's a good way. So we have to make sure that we keep the equation the same by factorizing out, and then hopefully that reveals something nicer.